All right, hey, ladies and gentlemen, this is section 4.5, limits at infinity. This goes pretty quick. Think about for a moment just conceptually what a limit is. And if you say your limit as x goes to infinity with respect to f of x, maybe you have some picture that does graph that does something like this. And what I want to know is what is the output value, or what is the y that this approaches? Okay, in this case, f of x, and it's kind of like a horizontal asymptote. Okay, your horizontal asymptote is kind of like the boundary that determines what this limit approaches. Okay, so you can kind of look at those as one of the same idea. And if we can remember from the very beginning that hey, the limit as x goes to infinity of 1 over x. Remember, as this gets bigger, your denominator gets bigger, your whole fraction gets smaller, and that will go to 0. Okay? And if you can kind of keep that in mind, then you're in pretty good shape. Okay? If you have your variable in the numerator, okay, then this, of course, goes to infinity. Okay? As this number gets bigger and bigger and bigger, then yeah, it'll approach infinity. All right. Okay, assuming that x is positive. So what do I have here? Well, I can evaluate this looking at it two ways. I can say that this is the limit as x approaches infinity to the value 1 plus the limit as x approaches infinity for 1 over x squared. And, well, the limit as x approaches infinity for 1 is just itself. Okay? And for the limit as x approaches infinity of 1 over x squared, well, we've already said that if it's 1 over x, that this is equal to 0. This would mean it would get closer to 0 more quickly, just the fact that that x is being squared in the denominator. And so this will also be 0. And we'll put 0 as 1. All right, so the next one, same idea. Instead of having an x squared in the denominator, I have e to the x. So, but in the end, it doesn't change how I'll treat this. Okay, and again, the limit as x approaches infinity for this constant 1 is just 1. And I don't really like to write these in, but if you think about just e to the x, as this number gets bigger and bigger and bigger, it makes the whole bottom fraction get bigger. Okay, more visual like that. And the idea is that, yeah, 2 over some number that gets bigger and bigger and bigger will give you 0. Okay, so 1, okay, plus this 0, okay, is equal to 1. Okay. You don't have to show this funny stuff here. This is just me kind of making some silly notes to help me kind of conceptualize what 2 over e dx is when the limit goes to infinity for that, as x goes to infinity. All right, now you'll notice here that you do have an x in your denominator, but you have also an x in your numerator, okay? And the highest power for your numerator is the term 8x to the first, and the highest power in your denominator is 4x to the first. All right. The negative 1, sorry, the subtract 1 and the subtract 2 are fairly insignificant when you think about x going to infinity. All right. As this gets super huge and bigger and bigger and bigger, these items in the back are somewhat meaningless. Okay, they play a very small role. So we just look at the 8x and the 4x, and since the powers are the same, okay, they kind of disappear, and you're just left with 8 over 4, which in the end is 2. Sometimes when you consider all the items that you have here, the x on the top, in the numerator, has a power of 1. The highest power you have in the denominator is x squared. And so you have to ask yourself, which will increase more quickly? The subtract 7 again and the plus 5x are somewhat meaningless, okay, because they're smaller terms with respect to their powers, and so they don't have a strong influence when you compare to the other terms with bigger powers. Okay? And so the biggest power for the numerator is an x to the first, the biggest power on the denominator is x to the second, And so this one increases more quickly, okay? And because of that, this will go to 0. Some people sometimes like to reduce this, and then it appears like the very first thing that I got, okay? So, and that's under the assumption, again, that these back terms are not significant. So in the end, you will get 0. This one's not much different. The highest power on the top is a power of 1. Okay, so that will give us a negative 2x for that term. On the bottom is x squared. And so again, the fact that this is negative really isn't significant, because whether you're going to positive 0 or negative 0, it just goes to 0. And that's all you need to know. All right, if we're good with that, let's go to the next screen. Give me a second, maybe pause this if you need to catch up a little bit. All right, and then we'll move on. All right, I'm hiding my problem here, problem 8. Put myself up here. I can look at the problems this way. Let's look at number 6. All right, again, the limit as x goes to infinity of x to the third. If you think about it, sometimes people are like, wow, it goes up and it looks like there's an asymptote just because it goes up so quickly. But while it goes up forever, it also extends out to the right in a more positive direction forever. So as x goes to infinity this way, it will go to infinity in the, I would say, the f of x part, or the y range, if that makes sense. So this will also go vertically to infinity. Same thing here. This is x to the fourth. This is a big power here. The items behind it, it's not that we don't look at those, but those are somewhat insignificant compared to what we have here with the x to the fourth. And this will go to infinity as well. So, all right, over here we have a bigger power on top. It's 3x squared. On the bottom, it's just a plain x. All right. Again, if you have a fraction with both variables in the top numerator and denominator, then you'll go with the one that's bigger. And if it's bigger on top, then you say, of course, it'll go to infinity. All right, number 9, just 3 left. Again, if you look at 4x on the top and x squared on the bottom. Now, some people will ask, hey, what's this cosine x? What happens here? Now, think about cosine. Cosine kind of looks like this. And I can put the intervals here, but that's not going to matter. What's important is that we know that it goes as low as -1 and high as 1. And so with this piece, as this gets bigger and bigger and bigger, all the cosine is going to do is travel somewhere between 1 and -1. Okay, so cosine of x, okay, will be somewhere between -1 and 1. I don't want to write for that. Where is this? I'll put this in green. It'll go from -1 to 1, and it will touch those. Okay, I'm hoping my notation is right. So if I'm only going to be adding values that are between -1 and 1 to this big number as it gets bigger and bigger and bigger, okay, then that part will not be significant. So power of 1 on top, power of 2 on the bottom. This is bigger on the bottom in your denominator. So this means this will go to 0. This one may be a little confusing because you have the square root. Looks like it holds a lot of stuff. But again, the subtract 5 right there is somewhat meaningless. Okay, so that will not serve a purpose as we think about giant numbers that can be inputted for x as we go to infinity, as those numbers get bigger and bigger. And if you think about x having a power here, this is really x to the 1/2 when you have that square root. And so you ask yourself, where is it bigger? Bigger powers here. It means this top piece will increase more rapidly than this bottom piece as x goes to infinity. So this increases more quickly. Okay, and again, because that's in the numerator, that'll go to infinity. All right, the last one. Here's just a constant, so that's just 8. Okay. All right, and so what happens here? This gives me an 8. Now, I don't like negative powers, so I will put that in another form. I'm going to say this is 1 over 3 to the x. And as this goes to infinity, this whole thing will increase more rapidly, and 1 over just bigger and bigger and bigger numbers will eventually give you 0. All right, that is it in a nutshell. I think it's one of the easier calculus lessons that we have, but if you have any questions, holler at me and I'll help you out. There's your assignments.